That was a very poor attempt to speak in Japanese. All right, so let's do it. Question 3. Let's do it. Let's do it. Let's do it. That. Just give me a second. I'm just going to format this super quick. So in the meantime, you could read the question. Alrighty. All right, this one's kind of crazy. Okay. So let's read this one together. We're really going to try to go through it as much as we can. And I'm going to probe you a little bit as we go through it. Okay? We're going to follow the same steps. So you are going to pay, and I guess we'll do it exam pace, just for you to see how I would maybe I would want you to do it. So we're going to highlight as we go through it. All right. So you're going to pay $800, all right, into an account. That's super important. So we're paying $800 into an account. That's solid. And it's happening at the beginning of each of 20 years. Okay, so at the beginning is pretty important. And then we're saying that this is happening for 20 years. Okay, and the first payment is at T0. The account will then be left to compound for an additional 20 years. Okay, so it's going to be left to compound. So that same account is going to be left to compound for an additional 20 years. Okay, shoot, it's interesting. And then at the end of the 41st year, okay, at the end of the 41st year, all right, you will begin receiving a perpetuity from the account. Okay, cool. That same account, that's interesting. And if the account pays 14%, okay, that's interesting. How much each year will you receive from the perpetuity? Okay, so how much, that's important, how much money am I going to receive each year? Okay, it's not bad. I guess I'll highlight this in another color. So how much money will I receive each year? We'll put that in blue. Will you receive from the perpetuity? Okay, so it seems like we're dealing with the same account. Interesting. Now, obviously, if you see this on an exam, you're probably like, what the hell am I even reading, right? This is a lot of stuff. And how I would look at it, especially with a question like this, I believe the first step in a question like this is really to maybe draw it on a timeline. I believe that would be the first thing. Maybe you could have like a small, nervous conversation with yourself at the beginning to kind of pinpoint that, okay, it seems like we have a lot of components of a lot of different sorts of formulas, right? The first section of the question is talking about the beginning of the period. When and where do we hear about payments happening at the beginning of a period? Would an annuity do? Okay, so that's one bucket. Interesting. Then another bucket of the question, another segment of the question is telling you, well, we're going to leave money just to be compounded. So just something to be compounding interest for an amount of time. Okay, well, that's another section. Then if we go at the before last sentence, it's telling you, okay, well, at the end of the 41st year, you're going to start to receive a perpetuity. So it seems like if we are just kind of trying to highlight a few pieces of the question, it seems like we're dealing with 3 buckets. So 3 segments. Okay, it seems like we're dealing with 3 segments. The first one seems to be dealing with an annuity due. The second one seems to be dealing with just compounding interest. Then the third one seems to be dealing with a perpetuity. Okay, so listen, is this telling you what to do yet? Maybe not, but it is putting you in the right direction. This is how I would brainstorm with myself on this sort of question. You want to think, okay, so 3 segments, 1 segment's an annuity due, the second is a compounding interest, and the third one's a perpetuity. Okay, cool, not too bad. From there, I would probably go with step 1, drawing our timeline, trying to visualize what we're kind of dealing with here. Okay, So let's go do that. Let's go draw this timeline. Now let's zoom in here, zoom out here. And now I'm going to ask you to interact in just a bit, so don't you worry. Okay, so let's draw our timeline. We'll make it a little bit better. So let's say T1 is this. And we'll skip a few years. We'll go all the way to T18. Go to T19. Oops. Go to T equals 20, I guess. I'll add one more just for fun. Okay, so we have a little timeline here. All right, so we have a little proxy timeline. What I tried to do is I tried to highlight a little bit of the important pieces, right? So we have T0, we have year 20, we have year 41, we have year 21. Like we have a few numbers, and with that, we're gonna try to like pinpoint a few pieces. Okay, so let's begin with the first segment. Can somebody tell me where would I put this $800? They're telling you that you're going to pay $800 into an account. Where would I put that within our timeline? Can somebody tell me? Where would I put that within our timeline? Where would that be? That $800. When and where? Okay, so the first one, yeah, I like that, is at $800. Okay. Now let me ask you this: when would our last $800 be? If they're telling you that it's happening at the beginning of each of 20 years, okay, when would the last one be? Obviously, we're going to have one here. Obviously, we're going to have one here. Obviously, we're going to have one here. But this is where the nuance kind of lies, right? I need everybody to give it a shot. Is it T19 or T20? William says T19. Bianca says T20. Okay. I need more people to give it a shot. Okay. More people to give it a shot. When is our last $800 going to be? William says 19. Bianca says 20. Bianca says 19. Okay. What about Waleed? What do you got? What do you got? More people. What's up? Where are we at? Okay, you know what? I won't waste our time. So we got 10 minutes. Waleed says 21. Okay. Well, let's read the question together once again. You're going to pay $800 into an account at the beginning of each of 20 years. What does this mean? This means that for 20 years, you are going to pay $800 into an account. That means that 20 times you are going to pay $800 into an account. So for sure, 21, it can't be because you're going to pay 20 times. Okay. But now the nuance lies in when are we starting those payments? Well, we said we're starting them at the beginning. So today at T equals 0. So if you started, as Bianca said, amazing, so good. If you started at T equals 0, well, then you could literally use your fingers. Okay, 0. So it happened at T equals 0. So we have 0, 1, 2, 3, all the way to the 20th one, which is going to happen at T19. At T19, you would have made your last payment of those 20 payments. So $800 would actually stop at T equals 19. So that's a nuance. You really want to be able to visualize that within your timeline. It's really good to have that intuition, okay? Then we're telling you that for the next 20 periods, okay? For the next 20 periods, you are going to be essentially compounding interest, all right? So for the next 20 periods, you're going to be compounding interest all the way, all right? All the way to T equals 40. Now, one thing that I'd like to note with everybody here, that for sure, I guess we could write it here. For sure, you're going to be compounding interest, and I'll put them in yellow. all the way to this date, right? For 20 additional years, you're going to be compounding interest, okay? So for 20 additional years, you'll be compounding interest, such that you're going to get an amount called FV40. I think so far so good, right? The idea of compounding interest is pretty straightforward. You know, it's just your compounding interest, pretty simple, okay? But now this idea of the third segment, which is our perpetuity. So our perpetuity, they're telling us, yo, at the end of the 31st year, you're going to receive I guess, yeah, whatever. You're going to receive a payment, okay? You're going to receive a payment at period 41. This is very interesting because this payment, because this payment is a portion, it doesn't stop at year 39. William, that's an amazing question. The reason why it doesn't stop at year 39 is because with the formula of a normal annuity, you got to remember what, actually I can just show it to you. Remember what our formula for our growing annuity is that you're adding a compounding interest at the end. Because you're adding a compounding interest at the end, it's like if that last payment that you received is going to be compounded for an additional period, such that it's going to bring you your future value at FV20. Okay, that's like a very, like, I wouldn't say it's like a nuance. It's like really the devil does lie in detail here. Okay, but now we are at the last portion where we know, if I go back on the screen, we know that, okay, at the end of the 41st year, you will begin receiving a perpetuity from the account. So we know that this is what we're solving for, by the way, and we know that that's going to occur right here. Okay, so far so good. We were able to define all of the different portions of this question. You just want to be able to visualize it. That's really the first, like the nuance of what we're doing. So if we were to like maybe color code it, we would say, okay, T0 all the way to T19 is one portion of the question. And then T20 all the way to T40 is another portion of the question. And then we would say that T41 all the way to infinity is another portion of the question. So we could say that this is part C, this is part A, and this is part B. Okay? So that's kind of like the timeline that you want to be able to have. Obviously, this is on an Excel. It's not beautiful and perfect, but you want to have that in mind. So like any strong student, you would say, well, okay, there's a lot of information, but what I'll do is, because I know we have 3 segments, I could at least try to plug these things in within my formula. And obviously, I'm looking for some sort of money in the future. So for sure, I'm seeking some sort of future value. So the first step, or I guess the second step, would be to solve our annuity. Our annuity due. And in this case, what I'll ask y'all is, you're going to use the formula, and I guess I won't screenshot it. I guess I will. You're going to use the formula, I guess, and you're going to try to tell what the answer is, okay, with the information provided. I'll even give you I'll just put the formula here, and I will ask you to solve for your annuity due. Oh, sorry about that. Give me a sec. There you go. So this is the formula of a normal annuity. That's the formula for future value of an annuity due. I'm going to ask you to use this formula to tell me what would be the future value of this annuity due that we have in this question. And as we said before, you always define your payment, you always define your K, your N. In this case, that's all that we need. So could somebody tell me, what is our payment? Just really quickly, we'll make it fun. And then after that, you just got to plug it in within your formula. But you'd be surprised. For some reason, plugging stuff in within the formula is hard. And it tends to be like the root of all evil. So what is our K? What is our K? What is our K? Waleed or William, what do you got? What is our K? 14%. Amazing. What is our N? What is our N? Somebody tell me, please. Bianca, you got this. I know Bianca has the answer. Bianca, what is our N? What is our N? I know you got it. I know you got it. Exactly. Beautiful. Amazing. Great stuff. Okay, so we have everything that we need. With that, can I please ask y'all to tell me what is our future value 20? And I guess I'm going to ask William to tell me what's our future. Actually, no, Waleed, what is your future value 20? Everybody could write in the chat, but I definitely want Waleed to give it a shot. So what is our future value 20? If you use the formula, and after that, I'll go through it quick because we're almost out of time, but super fun stuff. We're solving, well, what are we solving for, right? What is once again, when we're dealing, and this is a really important, like super strong key takeaway. With time value of money questions, especially with time value of money formulas, once again, we only have to look for 4 variables once we have our formula, right? Payment, K, N. And if G, if there is one, we would use that. In this case, we're dealing with a annuity due, and we're looking for the future value of this annuity due. We have all of the inputs. We have payment, we have N, and we have K. All that we have to do is literally just plug it into the puzzle, and it's going to give us an amount. We're really throwing stuff into the wall, and it's going to give us something. But you don't need I, right? There's no I in this thing. It's 1. It's 1 plus K to the power of N, right? So 1 plus K. Yes. So what is future value 20? What is future value 20? I'll give you guys like 20 seconds. That's pretty funny. To give it a shot. And after that, we'll call it a quits. And I'll go through it step by step. Thank you so much, William. That's amazing. Perfect. So that's our value right here. That's going to be our value that we have right here, future value 20. Okay, that's super solid. But once you have your future value 20, what are we doing? We're letting that amount compound, essentially accrue interest for an additional 20 years. So how would we do that? We would write that down as simply being future value 20 times 1 plus K to the power of 20. That's for step 2. Now we're essentially doing B, which is compounding interest, right? So once you found your future value 20, that amount we said in the question, the account will then be left to compound for an additional 20 years. So can somebody tell me, what is this amount? If we were to do FV20 times 1 plus K to the power of 20. William, you already have the answer. Can you tell me what that would be? If you just do that quick math, I'm sure it's still like on your calculator. What would that give you? For some reason my stuff stopped working, but Yeah, so it's essentially 1.14 million. For some reason, there you go. There you go. But yeah, William, you did great. Exactly. So that's exactly the answer. You could round it up to this. Okay. So then we have our future value at 40. Could somebody in the chat remind me what is the formula for a perpetuity? Could somebody in the chat please remind me what is the formula for a perpetuity? We said that it was PV0 is equal to payment 1 over K. In other words, we could say that a perpetuity, yeah, what's up, William?
Quick question. What's the 1 million answer for again? Like the F,
Oh yeah, no
the
problem.
compounding.
Yeah, so in the question, right, it kind of follows a timeline. In the question, it says, okay, you have a set of money, 800 bucks, that you're gonna essentially pay every single year at the beginning of the year, right? And that's gonna give you obviously a lot of money 20 years from now. And we noticed that, okay, well, if we were to do that for 20 years, we actually end up getting 83,000 some dollars, right? At this amount here, at year 20, okay? Then that $83,000 that we have, we're gonna let it compound for an additional 20 years, such that you're gonna have a lot of money at T40 in essentially 40 years from now. And with that, what you're gonna do is you're gonna receive a perpetuity from that, okay? You're gonna receive a perpetuity from that amount, from that same account. They're gonna take that amount and they're gonna allocate essentially a perpetuity from that, okay? But what's interesting is if we go back here, what's really interesting is that we get, no problem, we get PVN, okay, is equal to payment N plus 1 to the power of K. So what's really interesting is that if you understand that, you could kind of, and obviously the more questions you do, the more you'll see us using this like tactic. But in this case, if you understand that, you can say, okay, well, if payment is at period 41 in this question for a perpetuity, then technically PV that we would need is the one at year 40. But what's awesome is that, do we have something at year 40? Do we have something here at year 40 by any chance? Would that be possible that we have something at year 40? Do we have something right here at year 40? Do we, yes or no? Yes, we do. We have the future value at year 40. And obviously future value at year 40 is the same thing as present value at year 40. At year 40, your amount of money will be exactly what you have at year 40. You know, your what future value means is like literally we're telling you, hey, how much money will you have 40 years from now? And then that person 40 years from now will say, well, that's the amount of money I have today in the present 40 years from now. So it's really important to understand that PV40 is equal to FV40. It's the same thing, okay? Super important to understand. So with that said, now what we could do is we could solve for payment 41. We could solve for the perpetuity. So payment 41 over 0.14 is equal to that FV40 that we got below, that 1.1 something million. So can somebody tell me, by using this, can somebody tell me what is our payment 41? Can somebody tell me what is our payment that's happening in perpetuity, i.e. what is the answer? So we have payment 41 over 0.14 is equal to FV40, in other words, 1.140912.212. What would that give us? Hallelujah. I love to see it. Exactly. It would be 159,727.70. And you could round it to the nearest 1,000. That would be 160,000. All right. That's how you solve a large question. Now, obviously, because we spend so much time kind of talking about theory and we're running slow on time and I'm using my mouse to solve the question with you, it's not the smoothest process. But I do hope that we were able to kind of like break this question down into some sort of bite-sized pieces that you could maybe think about afterwards or review after this session.